Well, good morning, my people. Trying to get out this study guide for you with video solutions as soon as possible. Notice that there is the PDF solution that's already posted on Learn. Okay, so yes, you have a test next class period. It is open notes and open study guide. So can you make a script for yourself on questions? Yes, you can. These are hard concepts, and I want you to be ready. Okay, and number one, we looked at this one in class, where we see that it's a division problem, which that means for this is just taking out a greatest common factor. So we can use the heart method to do this, and it's that simple, right? Most people didn't have a question on this, so I'll move on. Number two, we could either choose to use long division, or we could choose to do factoring. If we chose factoring, we would have used AC method, and when we factored, we would have gotten m plus 3 times m minus 4 divided by m plus 3, canceled out the m plus 3 with a remainder of, it went m minus 4. And long division, we would do the long division. We did these both in class on the board. If you have questions on that, I look at the key that's on PDF. All right, number three, we have to first put it in standard form. When we do that, we see that we cannot factor this, that we have to use long division. Using long division means that I look at x to go into x squared, it goes x times. I multiply that out, and then I have to take it away. I bring down, and I see that 3x plus 6. It goes 3 times. I distribute the 3, and then I have to take this away. My remainder is negative 12 over our denominator. Brings me to number 4, which is also a long division, but with this situation, I see that I do not have a b value. Because there is no bx, I have to represent that place value with a 0, or when I do my long division, it will get confusing. So now I go ahead and divide by 2m minus 1. I see it goes 2m times. I multiply that out, getting 4m minus 2m, and I take that away, getting negative 2m squared plus 2m. I add that up, and I end up with 2m. I bring down the 13, it goes in 1 time, and I take away the 2m plus 1, because a negative, taking away a negative is a positive, and I end up with a remainder of 14. Number 15. In order to do this rational expression, I need to factor first. When I factor, I go ahead and use the X box on the bottom, and now I have to pause. Before I can simplify this expression, I'm going to go ahead and list my excluded values. Excluded values, remember there's 2 fraction no-nos that we talk about this quarter. The first fraction no-no is you can never have a 0 in the denominator. Why is that? I cannot divide something to make it disappear. I can only subtract it. So if like I had a cookie and I divide it amongst many friends, we just have a bunch of cookie crumbles, but it never disappears. But if I have a cookie and I eat a cookie, I take it away, then I have no cookies, right? So I cannot have a 0 in the denominator. So my excluded values are going to be positive 4 and negative 3, because those would have made the denominator become 0. After I found my excluded values, this was when I finally get to simplify and solve. Number 6, again, factor first. I have some opposite twins on top, x plus 8, x minus 8, that difference of 2 squares, and identical twins on the bottom, or perfect trinomial, x minus 8, 2 of those, and I can see that the one excluded value is 8 because they're identical twins, it's only 8, and then I finally factor to solve. Number 7, multiplying these fractions means when I multiply them, I can make them as one big fraction, but I factor again. It's all about chapter 7 and factoring. Once I bring out the factors, I see that I can reduce the 2's and another pair of 2's. And between 5w on the top of the fraction, between w to the 5th on the top and w to the 6th on the bottom, w to the 6th wins by 1, so it's 5/6w. Number 8, I factor first. This is going to be a scenario where I have something's not factorable, a GCF, that's on the top, that's 4y, which leaves me with y plus 5. On the bottom of the fraction, I take out a negative 2y with a y plus 5, and y squared minus 4 is a difference of two squares or opposite twins. Once I've factored everything out, I find the pairs that I get to take out, and I reduce this fraction of 4 over negative 2 to be negative 2, and then y plus 2 on the bottom. Number 9 is a division problem with fractions, which we use our keep, change, flip. I keep the first fraction, but I factor it. And I change to multiplication, and I flip the second. Finding the n minus 5 is reducible, and I multiply straight across to see what's left over. Number 10 is also a keep, change, flip. I just have 4 very different things to factor and the different factoring methods I need to use. So I use an X box and then an X box. And then on the right downstairs, I first take out a greatest common factor of 3 so that I can X box it. And then the top fraction, which I now move to the bottom because it's the flipping, I take out a GCF of 9a squared. Then I can simplify and reduce my fraction, dividing by 3. Number 11 and 12 just asks for the lowest common denominator. And I know the word lowest feels like it's smaller, but the only way to get a common denominator is to make sure that they have the same multiples. So I go ahead and factor out that first value, getting 3 times 5 and v squared. The other value is 4 times 5 and v to the 3rd power. So the first fraction is missing a 4 and a v, and the second fraction is missing a 3. Once you give everybody the same thing by multiplying, you can see what they would now that they're the same, what is that? Well, 3 times 5 times 4 is 60, and v to the 3rd power. 12, I need to X box both of them to see what the denominator already has and what they have in common. What they have in common is a u plus 1. The first fraction is missing the u minus 3, and the second fraction is missing the u plus 7. And I don't need to multiply this back out. I just know that it's going to be these 3 binomials together of u minus 3, u plus 7, and u plus 1. We do that to then on 13 through 16, we have fractions that we have to first get a common denominator before we can solve. On number 13, we see that it is a subtraction problem. And because it's a subtraction problem, I need to apply that negative to the whole second fraction, the numerator. I can't just subtract the 9x. I have to distribute a negative 1 to the entire binomial. Once you do that, they already have a common denominator. I just combine my like terms. 14, I have to get a common denominator first, which is going to be 18 to the 3rd power. So the first is missing a 3a squared, and the second is missing a 2. So I multiply that to the top values, the numerators, and see if I can combine any like terms. So I end up with 15a squared plus 2 all over 18a to the 3rd. 15 is a subtraction problem. We first have to identify that and attach the negative to the 5. Once we do that, we find our lowest common denominator, which will be multiplying them to each other. So the first fraction is missing the x plus 3, so we distribute that to x in green, getting x squared plus 3x. The second fraction is missing the x minus 4, so we distribute a negative 5, getting negative 5x plus 20, and we combine our like terms. This is not reducible because I know I don't have two numbers that multiply to be 20 and add to be a -2. So I know it's not reducible. 16, again, I need to change it. It's a subtraction problem. So I distribute the 3 and I Xbox out to see what my factors are on each side. The first fraction has a difference of 2 squares, c plus 1, c minus 1. And the second is the factors are c minus 6 and c minus 1. So altogether, the common denominator will be c minus 1, c plus 1, and c minus 6. Meaning that the first fraction is missing the c minus 6, so I distribute that. And the second is missing c plus 1. So 2c times c minus 6 is 2c squared minus 12c. And -3 to c plus 1 is -3c minus 3. Combine my like terms, check to see if I can reduce this, and I can't. This would be an AC factoring, so there's not two numbers that multiply to be -6 and add to be -15, so I know I'm done. Number 17. 17 goes back to our proportions that we had in pre-algebra and in the first chapter, where if a fraction is equivalent, then my cross products have to be equal. They have to be, right? We talked about this before. If I have 1/2, that equals 2/4. So if I do my cross products, 2 times 2 must equal 1 times 4, and 4 does equal 4, so we know it's true. We do the same thing here. So because it's equal, not if you're adding fractions, not if you're multiplying, but only if they are equivalent. That equal sign really matters. So we distribute the 4 to the x plus 1, and we distribute the 7 to the x plus 4. And then we simply get solve for our variable using our inverse operations, or letters on the left, numbers on the right, and simplify. And we get -8. And you can see this is true. If I go back to the original equation and I substitute in -8 for this, what looks to be a complicated fraction, I get 7 over 8 minus -8 plus 1, which is -7, equals 4 and -8 plus 4. So I end up with 7 over -7 equaling 4 over -4. Which obviously is -1 equals -1. So the one and only one solution is -8. Okay, number 18, though, is not an equivalent fraction. It's an addition on one side and it equals a fraction on the other, which means we have to get a common denominator. So we go ahead and get this common denominator and we find out what we need to multiply the top two. So the first value is missing a 3, the second is missing an x minus 1, and the third is missing a 3. Once we get a common denominator, we no longer need the denominator because this is an equation. We're solving for the x value on the top. So once we do that, we go ahead and combine our like terms and isolate our variable. We related this to the whole slices of pizza at the boardwalk. If I work at the boardwalk and I have pizzas that my boss is asking me how many slices I have left, right? And if he sees that there are some slices on one pizza over here, I would say I have 2/4 over there, and then I'd have 1/4. It looks like I have 3/4 of a pizza, but that's not what he's asking me. He's asking me, how many slices do we have left to sell? And there's 2 from here and 1 from here, giving me a total of 3 slices. And that's why when I have my denominator, I no longer need it because we're asking for the slices. Okay, which brings us to our word problems, and we put together all these concepts. If you can weed your neighbor's garden in 3 hours, working with your brother, you can complete the same job in 2 hours. How long would it take your brother to do it on his own? So we need to make some equations here. Let's represent ourselves. Everything's going to be a job over hours, right? Jobs over hours. You take one job in 3 hours, or job in 3 hours, your brother, right? We're doing jobs over hours, right? J is for jobs. Your brother is one job, the same job, and we don't know how many hours. What do we do know? We know that when we do them together, right? The one job for me takes 3 hours. The one job for my brother takes, I don't know how many hours, but we know together it's a one job in 2 hours. That's why it equals 1/2, because it's the one job over the 2 hours, right? One job, 2 hours. Now that we have written our equation out, we can get a common denominator, which is going to be 6x. So the first, I'm missing 2x, my brother's missing 6, and it equals is missing 3x. So once I have the common denominator, I don't need it anymore. I can get rid of it and only solve for the top. So I multiply all those values to the top and I get 2x plus 6 equals 3x. And I isolate my variable, finding out that my brother's going to take 6 hours for the job. He's a lot slower. All right, number 20, last question. You and a friend share the responsibilities of delivering newspapers on a newspaper route. You take 2 hours to deliver and your friend takes 3. Now, how long will it take you to do the job together? This seems like an impossible thing to think through. But when we know our fractions, it's not that hard. So what do we know? We know we're going to do jobs over hours. You take one job, it takes you 2 hours. Your friend takes one job, it takes the same job, takes 3 hours. What we don't know is how long it will take if we add the 2 people going together. That's why it's 1 over x hours, because we don't know. But it's always representing the one job. Once we have our equation, again, we get a common denominator, and we multiply whatever's missing to the top values. We get rid of the denominator and just solve for our equation. And we see 5x equals to 6, or the job together is going to take 6 over 5, which is 1 1/5 hours, which is basically an hour and 12 minutes. All right, don't forget, this is Open Study Guide, open notes. Can you write yourself a script? Yes, you can. Let's be successful on our last test. Talk to you later. Bye.